Question 6, we're going to get into elasticity of demand. So I have the formula already for elasticity of demand looked up. With this in mind, there are a few formulas you will want to know that you will have to have remembered. Notice the question does not give us the formula, so I would have elasticity of demand, and I'll put a note, I'll put a file with the ones that I think are important. What you're going to need to do is study them to the point where you can remember them. Before you take the test, review them, and then as soon as you open the test, on your blank piece of scratch paper, write down those formulas. Don't wait, because once you start into the test, your mind starts thinking of other things. It's more likely that you're not going to remember them correctly. Like the one I have with the elasticity, is there the negative here or not? Yes, there's a negative. X, which is X is the price. So some places they use that as P and Q, and these are your demand functions. But anyway, just a tip for preparing for the test, you do need to know these. These will not be provided for you. So the best way to do is put them in the memory, do a memory dump at the first step before you start working on that first question. Write down all them. Oh, they're there. Now you can focus on the various questions, and the formulas are as fresh as they can be because they are on your scratch paper. Okay. Find the equation for elasticity. So this is it. Here it is. Now, we don't just write this one. What we do is we write we take what they've given us, that the demand function, you call it Q or you call it D of P, is 491 minus P. Okay, so then we plug that in there. So really here, X is the price, so X is equal to P. So wherever we see an X, we're going to put a P. So for us, the elasticity function is E of P is going to be equal to minus P, the price, times the derivative of the demand function. So the derivative of the demand function is just going to be minus 1, right? Take the derivative of P. Derivative of 491 is 0. Derivative of negative P is negative 1. So times negative 1 divided by the demand function, which is 491 minus P. So simplifying a little bit, the negative and negative make it a positive. It's just P over 491. So P over 491 minus P. Need to. Okay. Find the elasticity at the given price, stating whether the demand is elastic, inelastic, or has unit elasticity. Unit elasticity means it's equal to 1. These other two, if it's greater than 1 or less than 1, right? So elastic happens when it's greater than 1. Inelastic is when it's less than 1. And then unit elastic is when it's equal to 1. Obviously, it can't be equal to 490. If P was 491, we'd have 0. But okay, so let's do this. 99. So we use our function. E of 99 is 99 divided by 491 minus 99. Make sure we do that part first. Let's go ahead and call on our little calculator here. So 99 divided by, now just make sure you get this in parentheses. If you don't, you won't get the right answer. Order of operations will do things differently. So 0.25. Oops, sorry. Come back over here. 0.2526. I don't know how many decimal places they want. Type an integer or a fraction. Okay, so they're going to want 99 let's go to red. They're going to want it as 99 over, let's see, 3. This is 8. 91 minus 99 would be 8. So that goes all the way, and then 8 more down is 392. Okay, which what we're going to do is the one I mean, I don't, yeah, it's less than 1, I guess you could see that, but I like decimals, just like John Dewey. So we would say this is when it's less than 1, it's inelastic, which means that a change in price does not change the demand tremendously. So we still have some room to go before we start affecting the price. Find the value of P for which total revenue is a maximum. Assume that P is in dollars. Find P for which the total revenue is a maximum. Now that happens when we have elasticity. When we have unit elasticity, we also get the maximum revenue. Okay, now it's not going to give us to get the maximum revenue, we take demand times P. So you could do it two ways. You could take the revenue function, take its derivative, set it equal to 0. Perfect. Or you could use the property that when we have unit elasticity, revenue is also maximized. That's what we're going to use because we're already almost there. So we take our E of P. Let's, where do we want to go? Again, always make sure you have enough room to work. Let's move this up a little bit. Let's see. Let's move that up. Okay. So what we want is we want our elasticity to be equal to 1. So P 491 minus P. And I like to think of 1 as sort of as 1 over 1. Then you can cross multiply. So you get that P equals 491 minus P. Just cross multiply. P times 1 is P. Okay. And then add P to both sides. P, not 5. Symbols, they kind of confuse me sometimes. 2P is equal to 491, and then divide both sides by 2. So about half of this 491 is what it's telling us. When we set that price, we'll maximize 490. And what does it want? Round to the nearest cent. Now they want decimals. Make up your mind, guys. Why not use decimals at the beginning? I don't know. It's just my thing. I think our educational system would do well to switch over to complete decimals. I know I get a lot of people still like fractions. I guess they do have. But you know what? Everyone has their ways. No one's completely right, at least not all the time. But hey, I'll admit I'm right sometimes. Okay, so $245.50. That is our answer that goes in here. So that's the price. It's not the maximum revenue, it's just the price. If you wanted to actually find the maximum revenue, then we go back, we plug it in here, and then multiply by the price. That's the actual, or let's see, can we even, this is the price, this would give us the demand, so that would, yeah, that's the amount that we would sell. So 245.5, subtract that's actually half, multiply it by 245, which is the price, and we got our revenue. Okay, but that's not the question. Anyway, hope that helped.